Hi, welcome to my channel, JaberTime, where I do math videos from algebra to calculus and differential equations, simplified with examples. And I also do some videos on apps and programs. If you like this video and you want to see more, hit the like button and subscribe. And if you have any questions or comments, leave them down below. I want to thank you for watching and hope to see you again and again. Thank you. Okay, now we have the derivative as a function. That's a second section for the idea about derivatives. The first one was introduction. Now we have it as a function. The derivative of f is the function. It's already a function. F prime of x equals limit of f of x plus h minus f of x over h as h approaches 0, provided that the limit exists, of course, and x is in the domain of f. Now, what do I mean by it's a function? Well, as you have a curve and as x changes, f of x changes. That's called a function. For every input, there is exactly one output. Same thing for f prime. Every point on the curve has its own slope as a tangent point. We're going to experiment more and more with graphs between two things, f and f prime. Those are two different functions. F prime describes the slopes, the behavior of the curve as you go. If the graph takes you up, going from right to left, we call it positive slope. If the graph is taking you down, we call it negative slopes. So those are the values or the behavior of f prime. If f prime exists, we say that f is differentiable at x. If f is differentiable at every point of an interval I, we say that f is differentiable on the whole interval. Let's take an example. Sketch the graph of f prime, the new function, now using the graph of f of x. You could see my style to do it and explain more and lecture. Even with my ideas, I end up doing lengthy videos compared to other teachers. And I want to show you more. That's why I'm showing the graphs. This is what I mean. See, doing the graph by hand in front of the recording, that's going to take a lot of time. So I did it on the side, then I'll go over it with you. Before I give you a comment, let's take a look. This is our first graph. Symbol graph in red, it's called y equals f of x. I'm going to take this piece right here on the right side. If I walk on this curve, on this piece, from this point to this point to this point, and I keep moving, and I refer to that as a slope. We know that the slope is positive if you are going up. Do you remember from algebra, rise over run, and so on? So for this piece right here, what's my slope? That's 0. But now we call it derivative. Derivative is the slope of the tangents. Kind of hard to imagine a tangent right here for this piece, but think about the slope as the derivative. So what is f prime when you are belonging to this region or this piece? F prime slopes of tangents, m tan, if you remember, is 0. Look at my graph. Where did I graph this piece? Right on the x-axis. Okay, this is done now. All right. Let's take another one. I'm going backwards, I think, instead of jumping around. So let's just keep going. You see this piece right here has a slope, fixed slope. So if I'm sliding or if I'm going up, rising, I mean climbing, not sliding. If I'm climbing on this piece, my slope is actually rise over run. but how far do I rise? It's, if you cannot see it, it's 5. You rise 5 and you run only 1. So what's my slope? Any point right here has the same slope, which is 5. So my derivatives, my f prime between 2 and 3 location as part of my domain is 5. Look, between 2 and 3, I should be always at 5. Okay, let's look at this one. Now I'm sliding. I'm not climbing. I'm going down. When you go down, the slope is negative. But what's the value of it? And it's fixed, right? Because it's not curvy. Going down 2, running 2. The slope is negative 2 over 2, which is negative 1. You see? Between 0 and 2, my slope is negative 1. It's right there. I'm leveled, valued. The value of f prime is negative 1. Look at this piece with the same concept. I'm leveled from negative 2 all the way to 2. That's a rise of 4 and a run of 2. So the slope is 2. So here the slope is 2, and you could see it leveled 1, 2, 3 up to 2. This has a slope of 0. I'm back to the x-axis. Now these corners, we call them corner points. You don't have derivatives. You can't graph a tangent here. If somebody says like, I think the tangent is like 45 degrees. No, you can't. How about somebody else goes like, I don't know, I think it's 42 degrees, like an angle of 42 degrees. You can't. I'm trying to speak simple explanations, like, you know, not advanced. But I just want to let you know, just keep in mind that derivatives on points like these guys, sharp edges, sharp corners, does not exist. All right, we'll talk about that more in the coming. Hopefully this graph, which is my first graph, I'm trying to slow down, is clear. Here's my comment. Notice that the slopes of the tangent lines change suddenly at x equals negative 2, x equals 0, x equals 2, and x equals 3, x equals negative 2, x equals 0, x equals 2, and x equals 3. Those are the points where I have those corner points. As a result, f prime at negative 2, f prime at 0, f prime at 2, and f prime at 3 are undefined. The graph of f prime of x has discontinuity at these points. See, this is continuous graph. This is f prime. This is f prime. It's not continuous. It's pieces. 1, 2, 3, 4, 5. Hopefully that's clear. Let's move on to another example. This time we have some experience, so we're going to go a little bit fast. Same topic. Look at this graph. It's not pieces, it's a curve, and we're going to discuss f prime. Let's take a look. After I graphed it, I marked it with black and red, kept it in red, kept it in red. To me, it's like 4 pieces to discuss and go over. From negative 2, 0, 2, and up. So kind of like you need to know where are we. Let's take a look at this also from the right side. For example, see this right here? If you are walking on this piece right there, marked, highlighted in black, you're going up. So your derivatives, your values of derivatives, we're not talking about how far or how much. We're not saying the slopes is 1, the slope is 2, the slope is 17. We're not saying that. We're just saying the values of the derivatives, the slopes of the tangents from 2 up is positive. So when somebody gives you a value like 2 or 3, where do you mark it? Do you mark it on the x-axis, above the x-axis, below the x-axis? Of course above, because it's positive. I think that's clear. You see it? So my curve for f prime, when I look at this, align it down here, you see the 2 graphs are aligned. This is up. This point has a horizontal tangent. The slope is 0. So at this x equals 2, I should be crossing the x-axis because my f prime value is 0. I'm gonna also cross the x-axis when x is 0. I'm gonna also cross the x-axis when x equals -2. So we have horizontal tangents at -2 and at 0, when x is 0, of course, all the way up here, and at x equals 2. I'm crossing the x-axis at these 3 points. Now let's look at this red portion. If you're going down, the slope is negative. F prime is negative. F prime values are negative. I should be graphed below the x-axis, which is true. At this point, I should go back to 0. And now down here, this point, you're going up like this guy here, so you should be positive. Between -2 and 0, you should graph f prime above the x-axis. And between -2 and 0, I should graph it above the x-axis. Here I'm going down, I should have negative values. Hopefully that's clear. Let's take another example. Let's look at this one here. This is with the vertical asymptotes. If you are going from here and up, instead of starting from right, let's go normally from left to right. On this piece, I'm going up. My derivatives are positive. My slopes are positives. My values should be above the x-axis. I am above the x-axis. Here, I'm sliding down. My slopes are always with negative slopes. I should be below the x-axis. Now, why it curves that fast or it looks like this, that's another topic to let you know how. We're not going to be talking too much, but I'll just give you a quick idea. Let's look at this point here. If this has a 45 degree with a slope of 45, like the tangent is right there making 45 degree, the slope is 1. So I should be at 1. That's my value. After this, look at the tangents. They go up and higher, steeper. So my values, my slopes, they increase so fast. My values of the tangents or f prime increases so fast. Hopefully that helps. Next. Theorem. Differentiable implies continuity. This is one of the theorems that we use in calculus. You're going to see more on the coming sections. If f is differentiable at a, we have the formula. F prime of a equals limit x approaches a of f of x minus f of a over x minus a do exists. So differentiable, if a function is differentiable, that means we do have this. This do exist. To talk about continuity, we talked about that earlier in a previous section. To show that f is continuous at a, we must show that the limit of f of x as x approaches a is the same as f of a itself. So this is kind of given. Differentiable implies continuity. So we're going to start here. We're going to finish here. Let me give you the proof. Here's the proof. We didn't do much proofs, but it's worth it sometimes. As I say always, the more that you know, the more skills that you have for anything that might come up. I'm going to start the following. I have the steps. Just follow me and we should be fine. F of x equals f of x. Everybody agrees on that. I'm going to subtract f of a. I'm going to add f of a. Everybody should agree on that. You might wonder, like, why are you doing this? Well, it's hard to tell you or convince you unless if you've seen it before or you have a vision of where you're going. We're gonna go from here to here. I need this. How do I make it? I want to keep this in mind, try to play around, and somehow end up with this. But anyway, just stick with me with the steps and we'll see what we're gonna have. Now, I just added parentheses right here to make it look good, because I have something in mind, and you will see why. I'm gonna multiply this package by x minus a and divide by my x minus a provided that x does not equal to a, because if x equals to a, that is 0, which means I cannot do that. All right? Now, why we're doing this? We are trying to take advantage of this form, which is right there. You see it? So we're cooking something, we're building something. So far you agree on the steps. Now I'm gonna apply the limit to both sides. Everything here with the limit and the limit of this as x approaches a. Now the limit of the product is the product of the limits and the sum applying the limit. So just basic limits rules will take me right there. When x approaches a, what happens here? A minus a, that's a 0. So that's going to be 0, and that's going to cancel, and here we go. Look, 0. This has a name. It's called f prime of a. They told me it's differentiable. This do exist and has a short name. So I'm going to, this right here, call it f prime of a, multiplied by 0. Limit f of a as x approaches a is not going to change. And it's going to stay f of a. So we have the limit of f of x as x approaches a equals to this package only by itself, because this one cancels. And that's what we want. Look, see? Okay. I'm going a little bit fast, but you have it. You could pause the screen by hitting the space bar, take a look at it, and move on. I thought going over it instead of skipping. It's good to know some theorems. Let's look at the theorem the other way around. The other way around is called alternative version. F is not continuous. If it's not continuous, then it's not differentiable. It's part of logic, by the way. You see this graph right here? Sometimes we discuss problems as like when this is continuous, when it's not continuous, when this is differentiable, and when this is not differentiable. From now on, we're going to talk about more about continuity. A graph, a function, is not differentiable at certain conditions. One of them is endpoints. At endpoints, if you have an interval, not your function is not defined on all real numbers, it just defined, let's say, from 5 to 7. We say it's not differentiable at 5 and at 7. Those are called endpoints. I don't have it on the slides here, right here, but this is like a bonus. Keep it in mind. Functions are not differentiable at endpoints. Now, f is not continuous right here at 1. You could see the jump. All right, we know this. We discussed that in previous videos. F of x is not continuous at x equals 1, so f prime of 1 is not defined, which means f prime of 1 does not exist, which also means f is not differentiable at x equals 1. Another graph. We have a hole right there. We talked about graphs with vertical asymptotes and graphs with holes, and how do they happen when you start factoring and simplifying rational functions. This graph is not continuous at this location, so it's not differentiable there. You can't graph a tangent that touches this, which is not even a point that belongs to the graph. I was going to say a point, but there is no point there. F of x is not differentiable at x equals -2. All right, it's not. Take another example. Now the curve is in red. You could see here it's curvy and curves the other way around. So with this point here, we call it corner point. If you approach it with slopes and tangents from this side, like you approach this point, if this is 2, yeah, it is 2. From the right side, you would have tangents like this guy. You see it? L2. But if you approach 2 from the left, you're going to be on this curve. But look, as you approach it, your tangents will look like the green line. That's completely different scenario. Your limit from the right, your limit from the left should be the same. To call it f prime. F prime is a limit. The limit do exist if the limit exists from right and left, and not only that, they do agree on the same value. So that is called a corner point that causes this kind of behavior in slopes and tangents. Tangents approach L1 as x approaches 2 from the left. Tangents approach L2 as x approaches 2 from the right side. So slope of L1 does not equal to slope of L2, so f prime of 2 does not exist. Take another example. Now this one here, kind of like this one, you could call it corner point, but it has another name. It's called Cusp, C-U-S-P. That's kind of like a sharp point. This is kind of concave down. This is also concave down. But look at the tangents. Your tangents here, as you get down and down closer to 0 from the right side, they will become eventually like the y-axis. Same thing right here. Those will go down. Negative slopes, positive slopes. F prime at 0 does not exist. We say the limit of fx approaches infinity when you approach 0 from the right. When you approach 0 from the left, you have negative infinity. F prime does not exist when you approach 0 at 0. This is another example. In this case, you might say earlier that because positive infinity, negative infinity does not exist. Not really. Here's another example. You are going up. For some reason, you start going curvy again. So this is kind of like steep, going straight up. Tangents, if you try to graph too many, eventually you're going to be with the y-axis. This is called vertical tangent. And if I ask you back again from algebra, what's the slope of a horizontal line? You're going to say 0. What's the slope of a vertical line? Delta y over delta x. But delta x is 0. You can't divide by 0. Undefined. So f prime of 0 does not exist. The limit from right is infinity. The limit from left is infinity. I know they both agree, but that's not an answer. That's not L. The limit has to be a number to call it does exist. When the limit is infinity, we call it does not exist. So f prime at 0 does not exist. So that's kind of like a summary where derivatives do not exist. Endpoints, discontinuity, if the graph is not continuous there. Corner points, cusp, vertical tangents, like this one, vertical tangents. I have an example right here, and we're going to go through it in detail. F of x equals 1 over square root of x. Find f prime of x and f prime at 25. What's the derivative? What's the tangent slope at x equals 25? It's kind of lengthy, but I'm going to take my time showing you step by step. First of all, f prime equals limit f of x plus h minus f of x over h as h approaches 0. That's f prime. We're going to find it. I'm going to take the time. Once I finish, you could pause the screen and look at the notes. But it's kind of hard to read every single thing. I'm just going to explain it. So just follow me. We know the first one, where it came from. Instead of f of x, we're going to write 1 over square root of x right here. Instead of f of x plus h, I'm going to write 1 over, just like applying the derivative, the function as defined. I want to simplify the numerator right here by combining them using a common denominator. The common denominator is you multiply them together because they're both different, and you end up with this. That's too much to look at. We call it in math mixed fractions. I have a fraction bar here, another fraction bar here, but this is the main one. That's why I made it longer. I marked it for you. When you divide, you could change it to multiplication, and you have to use the reciprocal. So instead of saying dividing by h, I say multiply by 1 over h. This is cleaner look compared to this. I'm going to pull this to the front, so I'm going to put the edge right here. I did. Now, we're going to play the game again from previous video, last video. I told you how to factor or to work on this one. This is like a minus b. When you factor difference between two squares, a square minus b square gives you a minus b times a plus b. So this is the a minus b part. We need the other piece. This is what I mean. So I'll bring a plus b. That is the factored form of difference between two squares. So that's my a square, no square root anymore. That's my b square, no square root anymore. But look, you see this cancels after I distribute the minus sign? I'm trying to tell you that to speed up and so you could follow me and understand what I'm doing. So that cancels and I have the minus right there. Now I could cancel the edge. Some students, they get excited and they start canceling, let's say this edge with this edge. You cannot do that. You have to wait till you can do it right. If this is edge plus 5 and you have edge right here, you can't cancel the edge because there's a plus next to it. It has to be factors only, something times something or by itself in this case. Now I have the minus 1. We'll keep it there, or you could take it all the way outside. You can. Now look here, I could plug in h equals 0 because that's not going to cause the denominator to be 0. This was the problem. This was the problem right there. We can't plug in 0. We do the algebra, we do the skills, everything we know to somehow cancel this. One example is not enough, but I'm giving you advices. In limits, all what you're doing, you're using your skills to factor, simplify, get rid of what is causing the denominator to be 0, and things will work nicely. Now let's plug in 0 here. Plug in 0 here, and I got a clean look. Square root of x times the square root of x. I don't need to write plus 0. Square root of x plus square root of x. That's 2 of them. That's 2 of them. Now pull the 2 up front. Now I have 3 of square root of x multiplied together. That means square root of x cubed. Or different, you could say 3 over 2 as an exponent because the square root is to the power half. Now here's a summary of the problem. F prime, because they want me to find f prime as a function, it's right there. Minus 1 over 2 times x to the power 3 over 2. And they want me to find f prime. What is the slope of the tangent at 25? The answer is negative 1 over 25. Just plug in the number 25. 25 to the power half square root, which is 5, times itself 3 times, and then double it, and that's what you have. 125 times 2, which is 125, 250. I tried to make it less than 30 minutes, and it looks like I'm able to do it. It's about that time. Thank you for watching, and I'll see you next time. Thank you for watching. If you like this video, hit the like button and subscribe. If you have any questions or comments, leave them down below. I want to thank you for watching, and I'll see you next time. Thank you.